Okay, welcome back. Like I said before, this next part relates to 7.3 in your books, not 7.2. So when you're going through and you're doing questions, skip 7.2, and anything that says critical value or critical region in a question, ignore that as well, because that's relating to 7.2, which we're going to look at the end. All right, what we're going to go through today is how we actually do a hypothesis test. So there's two types of hypothesis tests. One's called one-tailed test. The other ones are called two-tailed tests. So with a one-tailed test, we find our null hypothesis, and that's where our probability is equal to something. And then we state that our alternative hypothesis is where our probability is either greater than that value or it's less than that value. And that's what we call a one-tailed test. And when we're looking at a two-tailed test, it's going to be where our alternative hypothesis is not equal to that value, and that involves just doing a little bit kind of additional calculations. But for the moment, and for today, we're just looking at where we've got a greater than or a less than our predicted p-value. Okay, the second thing I have to talk about is when you're conducting a hypothesis test, there's around about, well, actually I can tell you exactly, there is 5 things that you must include in your solution when you're doing it. And it's very structured. It's very specific on the way that you need to work it out and the way that you need to present it. Okay, and if you do not present it like that, you will not get the full marks, and it's going to seem super frustrating and really long, but that's just how it is. So the first thing that we need to do, so this bit in red that I've written down here, normally you wouldn't write that when you're answering the question, but I've put it in there just because you probably want to write it down as you're going. You might even want to do it as it's like a table where you've got the stuff in red on one side and the other things on the other side. And yeah, so where you got one thing on one side, one thing on the other side. And then what you want to have is just the stuff that I'm going to write down in blue. That's kind of only what you should be including in your solution. Okay, so you don't need to write, for example, 1 to find the test statistic and p-parameter if it wasn't obvious already. Okay, but that is the first thing we're going to do. So our scenario is that we've got a normal 6-sided dice. Is it fair if only one 6 is thrown in 24 throws? And we want to test that at the 5% significance level. So the first thing that we write down is what our test statistic is. So our test statistic, which we're going to call X. X is the number of 6s obtained from a number of rolls of the dice. Or die, if you're using singular. The next thing is we want them to find what our p-parameter is. So that's what our probability is. So in this case, p is the probability of obtaining a 6. All right, so if the first couple of steps are all just defining what we know and what we want to find out. The next thing is we want to write our model. Okay, so that's when we talk about model, we're talking about what kind of distribution we're using and what do we know from that. And then what our hypotheses are. So in this case, our model is that our test statistic, X, is approximately binomial. We've got 24 trials and we're looking at a probability P. Now you can't write down what P is yet because that's what we're testing for. So at some stage, we're going to accept what P is, but we're not doing that for the moment. From there, we're going to then write down our hypotheses. So our null hypothesis is that P would be equal to 1 out of 6, 1 over 6. Okay, because we would expect for a normal dice, a fair dice, that we would expect approximately 1 6 out of every 6 rolls. That means that our alternative hypothesis, okay, is that our probability would be, now, a little bit tricky here, if we're talking about whether it's going to be less than or greater than 1 out of 6. Now, I would say for this question, we're looking at if it's going to be, I would say, less than 1 out of 6, because we know that we've we've only thrown 1 6 out of 24 throws, so that would indicate that we want to find whether our probability is less than 1 out of 6 overall. Right. From here, we're then going to calculate the probability of our test statistic occurring. So we assume that our null hypothesis probability is correct, and we always do that every time. We always assume, and that's why our null hypothesis is always an equal to probability, because we need to be able to assume that it's correct, and if it's an inequality, we can't assume it's correct. So we assume that our null hypothesis is correct. So that means that our test statistic is now approximately binomial with a sample size of 24 and a probability of 1 out of 6. All right. To calculate it, we then need to calculate that binomial distribution. And in this case, and we're going to look at a cumulative, well, whenever you're doing a hypothesis test, you're always looking at a cumulative distribution. And it depends on whether you're looking at a greater than value or less than value. It depends on whether your alternative hypothesis is a greater than or less than. Okay, so we are going to look at the probability that x is less than or equal to 1 out of 24. So we're going to use our calculator. I've got to remember how to use this thing again, please bear with me. So we want distribution, binomial CD, oh, I've almost got it, variable. Okay, so we have x is 1, okay, n is 24, p is 1 out of 6. But let me do 1 out of 6, or I'll have to do, oh, yeah, it will, 1 out of 6. Okay, so we can then calculate that. All right, and we end up with our probability that x is less than or equal to 1. If we do our binom, I'm just going to write, we always have to write this at home whenever we're doing it. So binom CDF 24, 1 out of 6, 1. Okay. All right, so I've done to 4 decimal places, so our probability ends up being with 0.0730. If we convert that to a decimal, that's 7.3%. All right. So if we think back to what we meant by significance level, okay. So yeah, like I said, if we were thinking back to what we meant by the significance level, if we rejected our null hypothesis at this stage, there would be a 7.3% chance that we would have incorrectly rejected our null hypothesis, which means that our null hypothesis would actually be true. And because our significance level in this case is 0.5, 7.3 is greater than 5, or 7.3% is greater than 5%. Okay, so therefore, there is not enough evidence to reject the null hypothesis. All right, and so therefore, the die is unbiased. Okay, so I mean, getting 1 6 out of 24 is probably an odd result, but it's not enough evidence at this stage to suggest that the die would be biased. All right, we're going to move through the next one a little bit more quickly. So the next one is an upper tail test. Okay, so in this case, we're probably going to be looking at greater than rather than less than. Okay, so in Luigi's restaurant, it is believed that 1 in 10 people order a bottle of champagne. Out of a sample taken of 50 people, 11 will order Chardonnay. Oh, sorry, Chardonnay, not champagne. Has the drink become more popular? Test at the 1% significance level. So again, the first thing that we do is we define our test statistic. So X is the number of people purchasing Chardonnay. Okay. We then need to define our probability parameter. So P is the probability that a random person orders Chardonnay. Okay. We then need to define our model. So our model is that X is approximately binomial. Okay, we're looking at a sample of 50 people with a certain probability. And then we then need to define our null hypothesis and our alternative hypothesis. So our null hypothesis, in this case, 1 in 10 people order a bottle of Chardonnay. So we would assume that our probability is 0.1. Okay, and we're looking to see whether the drink has become more popular. So whether our alternative hypothesis, the probability is actually greater than 0.1 in this case. Okay, so we're testing at the 1% significance level in this case. So we're looking at a much more kind of accurate test than we were before. So our method is that we assume, well, I haven't left myself a lot of room here. Assume H0 is true. Okay, so therefore our test statistic is now X is approximately binomial with a sample size of 50 and a probability of 0.1. We then do that calculation. Now in this case, we're looking at the probability where X, because we're looking at an upper tail test, okay, so because our probability is greater than 0.1, okay, we're looking at the probability where X is greater than or equal to 11, okay, because we found that 11 out of the 50 people order Chardonnay, so the probability that X is greater than or equal to 11. Now remembering that our calculator can't do greater than probabilities, so what we're looking at here is actually 1 minus the probability that X is less than or equal to 10. Okay, so we calculate that. Distribution again. Okay, X is 10. Our N value is 50. Okay, our probability is 0.1. Okay, we calculate that. We get 0.99. So 1 minus 0.9906. Whoop, too many 9s in there. Sorry, guys. Delete that. All right, and we end up with okay, so 9.4 times 10 to the negative 3, so that's 0.0094. Okay, if we convert that into a percentage, okay, we get 0.94%. Now, when it comes to, we were testing at the 1% significance level. So if that percentage had been greater than 1%, we would accept our null hypothesis as being true. But because that's less than 1%, we now need to evaluate it. I'm just going to do it on the side here because I'm running out of room. 0.94% is less than 1%. So we reject the null hypothesis as being true. And we sorry, I didn't mean to write we there. So we reject the null hypothesis, and our probability is therefore greater than 0.1. Okay, so then we can say that Chardonnay has become more popular. All right, I'm running out of time a little bit to do this last kind of further example. This is just the one from the textbook, so if you want to go through and have a look at it and copy it down, it's the example in your book, so that's fine. So you can go through and look at that. From here, I want you to do these ones here. So 7a and